Hello and welcome back to compiler programming. In the last few videos, we spent a lot of time on adding new features to the language, and now it's time to do some much needed cleanup and hardening of the stuff that we already have. I would like to start with work on the function calls, because there are a number of things that need addressing. The first thing is something that we noticed in the reprelative implementation, and namely that for functions, that just means we can use a different encoding, which we can find here. So if we go to call, there is this version that allows you to just specify a 32-bit relative offset and use this stuff for function calls. So let's do that and then continue to the next thing. In preparation for today's episode, I did a bit of reorganization, so I pulled out all the function and arithmetic stuff into a separate file and as well created a separate test suite file so that we can start organizing code a bit better, and especially for something like function that it has very well defined interface and a set of things that's supposed to happen, it's a good idea to have a separate test suite. Okay, so there is this somewhere over here, a bunch of commented out code where we started to deal with this relative address. So let's uncomment that and figure out what we need to do to actually make that happen. Okay, so the operand type should not be reprelative. Instead, it should be immediate. But we do need to somehow tell the... I guess here it's not immediate anymore because we are using register for a call, and these are two different instructions. So we have this ff2 for the register, and then we have this one for relative 32 offset. So if you just pass immediate, that immediate will be interpreted as the 32 offset. So we need to make some assertions here to make sure that this immediate 64 actually does fit into 32-bit offset. So let's do a 64, relative 32 is, or relative offset. And now we assert that this relative offset is less than int max and more than, I think it's called int min. Let's check out the C int min. So there is this limits.h, except the stuff. Yeah, it's called int min and int max. So this is what we can use. We say that it's less than int max and more than int min, or other way around, maybe for readability purposes. Once we did that thing, now we know that it is safe to do the cast. So we can now do s32 rel 32, and it's gonna be s32 of relative offset. Or we can not even introduce this extra variable, do this check here and do it like so. Maybe that's gonna be better. Okay, we no longer need this reprelative operand, and instead we just say we want immediate 32 of this rel 32. Good. Now let's try to run the tests and see what happens. Whoa. Apparently I messed up somewhere else. Oh yeah. We uncommented this stuff and it caused a bunch of problems. So, assertion failed. this is less than int max. This is quite interesting. So what is this value? Oh yeah, because we do need this separate variable, because we can't just take this address as it is. We want to say what is its offset relative to the start of our memory, because our memory can be at any position that might just happen. So it needs to be like that. And this is why it's good to have assertions. They catch a lot of stuff. Okay. Let's check. Okay. Now that's good. The could not find acceptable coding is exactly correct, because we don't have yet the encoding for that. Actually, it's in the instruction. See. So where is our call? It's here, and we need to add another encoding here. It's gonna be 00 E8. And basically there is only one valid one with immediate 32. So we just say immediate 32. It does not have an opcode extension, so extension type is none. There is no opcode extension, and these are the operands that are happening. I think actually we don't need to put this nonce here. I think I learned that C will initialize it to 0, but this is something I still have to test. So maybe make this a bit smaller in the future. Okay, let's try that again. And well, it did encode the instruction, but something did not exactly work out once it did. So let's bring out the debugger and start looking into that. Actually, one thing that yeah, actually this is not how it exactly going to work, because we again need to do offset relative from the end of the instruction. So this immediate operand somehow needs to be specially tagged to say, oh, actually, please adjust that offset. How do we do that? I mean, we can also do it here, because we roughly know what it's going to be. So if we say that builder builder buffer occupied, or buffer memory plus builder buffer occupied minus size of S32. So this would be S32 star relative code offset for immediate. Let's call it that. It's going to be this. And we can probably cast this to what we want, which is S32 star. And cast this whole thing to it. I need to check what is the type of memory. It is U8, so that's good. Okay, that sounds about right. And now we can actually put stuff in there. And in here, instead of encoding this, I will just do some pattern that is easy for us to recognize when we override this. And again, we have different variations of this at different points in the code. They are all slightly different from each other, and it might be worth taking a long hard look and understand, can we like somehow merge them together, or is it better that they are actually different from each other? I don't know. For now, I want the functionality of this to work, because later on we'll also have a test suite that checks that all of this works, so we can do any refactoring that we want. Okay, so now we say star offset for immediate is I guess I can do it this way. I'm missing a semicolon, that's fine. Okay, that builds, it might actually work. Now, one thing to note here is all the stuff that I'm doing, especially these kind of things, is actually very non-portable code, because it expects that both the CPU and the system you're running the compiler on are a little Indian, or at least they have the same architecture, and that might not necessarily be the case. So like this is a bit of a fishy code when you deal with binary encoding, and ideally you would want to individually write bytes in the order that you expect the target system to consume. That's just a side note. Okay, let's try this again. Actually, no. Before we do that, we will need to do some calculation, because this is not the full value. The offset that we want is actually, yeah, all of this needs to move over here. And relative offset is not offset from the start address. It is offset from where we are right now to where that function is, and where we are right now is gonna be another thing where we say u8 star current address, and the current address is this thing. Yep, something like this. And now if we have current address, we basically do current address minus whatever, let me think, do we need minus or other way around? So if the function that we're trying to call is located before us, then this should be negative. So it is actually like this. Yes, if it's before, so if it's like 5 and this is 8, we will get a negative offset, and that's correct. And that way we will get positive offset if the function that we're trying to call is actually after where we are. And current address, we need to turn this into a 64 to allow to do arithmetic on it. Okay, now this should be good, I believe, at least. We will see. And indeed it is. All the tests are passing, and instead of, first of all, now we are not wasting move to register if we don't need to, and in general this encoding is way more compact than this one, and it's just a good thing to support, because it's set for when we actually end up writing binary executables, this is going to be necessary. So this is good progress. Let's end this, let's commit this and say we are going to, or I can do also this support rel32 function calls. And we can add more information. Previously, we would always put function address into a register rex and then use that for a call which generates unnecessary instructions and occupies a register. Good. So that's done. And now it is the next thing, which luckily has nothing to do with assembly or encodings or any of this kind of stuff. And it's simply about the niceties of the API. Right now, if we look at our tests, we have this call function value, which is very, very awkward to call. We need to specify a builder. We need to tell how many arguments we are putting in there, and it's just not a nice experience. So what I would like to do is I would like to have just call. You don't specify this stuff, and you also don't need to specify the count. So you just have this thing. And first, let's just define it right here and see how that might look like. So the first thing will be target. Yeah, target is good. And then we would have some number of arguments that we will call. Now, in C macros, the var_arg support is a bit awkward, let's just put it this way, and it is actually nicer if we can create a function that will slightly transform the arguments for us from whatever we are passing into a different form. And in particular, I think we will go with functions accepting variable arguments. I would still want to have a macro for not specifying the builder, and for the fact that if we go with var_args, we need to somehow indicate that we are done with our arguments. But apart from that, it should be fine. So what I want to do then is to change the format of this call. So, or this call. Let me think which one do I want to change. So we pass the argument list to here, and then we do call function overload, but we again pass, but we have this argument overload list here. So we unwrap the arguments. So in a sense, all the argument processing is happening in this function, and this is actually the function that we are calling. So this is the one I will now make slightly different. Let me comment this out to keep it the same, but to have a reference, I mean. Instead, it will now accept variable number of arguments. Unfortunately, in C, that also means that those arguments are untyped, and if you pass the wrong thing, it is your own fault. So that's not great, but it is what it is. I guess we will expect to pass the right things. If we do want to allow to have a bit more safety, maybe we could make it as well. Now that I'm starting to do this, let me try something. Let's undo all of this stuff. And I want to check, basically, can I inline define an array here and say this is a value star array? I'm not even sure how type would be. I guess like so. And it will have this stuff. So can I do this? Okay. Something did not go well. Yeah, here it's should be a comma. It wants an argument list, which means actually that it should be without star, so we are just passing an array here. And initializing value overload differs in interaction from value. I thought value from my 64 gives me back a value. And this is also a value. So what is the actual function spec? Call function value. Call function value is here. It wants an array of arguments as the parameter. This is what we are giving to it. Okay, first of all, let me try to extract this out. Say value args is this. And try to understand where the error is coming from. So it's coming from this thing. And am I mistaken for what value from a 64 actually returns? It returns a value. Okay. Yeah, so I guess if we want to make that happen, we would need to change slightly the signature over here to accept a list of pointers to arguments, which is a good change to make anyway. It will break a bunch of stuff, but that is perfectly fine. Yeah, as I said, it will break a bunch of stuff, but this is actually a good change to make if we can make it. So let's try to first do that, I guess, manually and see that it works. So we'll put back this stuff and try to make it in line, because if we can make it in line here, then we could do a very nice thing. Let me showcase what I'm getting at. So our goal is to not need to specify how many items we are actually providing this, right? So we want to get rid of this one over here. And this one is, again, necessary because we need to know how long to iterate for before saying that arguments are over. But we could do it in a couple of ways. One way actually, which would be the easiest, is to just put a 0 over here, and in our function call to check, okay, we got 0, that means that this was the last item and we are ready to be done. This is also how C strings are working. However, this has a bit of a problem that you can have accidentally wrong things, right? If you get a null pointer from some function, then suddenly it will be in the middle of the stuff and your code will work or not work by accident, and it will be very hard to debug of what is going on, right? Even if you have, for example, invalid pointers afterwards. So I prefer if we could not do that, but instead we will do a kind of a terrible thing where we will abuse size of, because we have static array size, right? We can have this macro that accepts an array and gives us what is the count of elements that is in there. And it even works with this stuff. So if we have a macro where we put the varargs over here, then it should be fine, I guess. Let's think. Okay, before I go and do all of these changes, I would like to continue making sure that I can make a macro that where this code will pass. So again, define all as it accepts a target and it accepts a bunch of stuff. And what does it do? Well, it does this thing. So obviously we'll need to turn this all into a macro. And as you can see, unlike the varargs, which would be untyped, so we just pass whatever you want and interpret it as whatever, here we actually pass in an array of very specific type. So if we try to pass in the wrong thing here, it will explode. And if you can make something type safe, it's usually worth the effort to do so. Okay, so now we have call, and we will need like call helper. And the reason we need to call helper is because we want to not repeat this array multiple times, I guess. Although who cares? Here we will do varargs, and this just means that this refers to whatever is passed over here. There is a bunch of compatibility issues where I believe in GCC you would need to do this if you wanted to for this to work with 0 arguments, but I think in MSVC it works either way. I can try to make it happen like this. Let's see. So this looks good. We replace this stuff here with wrapping it in braces. And let's try to make that call and say value star x is all of overload and value from S64 of 0. Let's see. Well, it doesn't look like compiler is complaining about this particular line, so that's very, very good. And we can start working on turning the rest of the stuff into this new and shiny form, which I like very, very much. This probably should go together with all the other stuff. So over here. And we might want to create one that has builder as the parameter, but that will come when we need that. Let's continue here. So I can search for this, I guess. And I will replace it with call. That sounds good. Okay, and we also need to get rid of these arguments. They're no longer necessary. Good. What is wrong here? I'm not certain. Missing interaction from no. Okay, what was written there? It was builder ID value from S64. This is kind of strange that it doesn't work here as well. Okay, let's just switch it out and then figure out later. First, we'll want to go through all the code and deal with it, I guess. I have a bunch of warnings in function spec. So I guess we want to also cast it to a particular type before we hand over here. So yes, this is an array, but what we also want to do is we want to turn this into a value star star, I think. Why are you unhappy about this stuff? I wonder. So what is going on over here? We call ID and the type of ID should be value star. So is it value star? Yeah, ID is value star like everything else. This is also value star. Okay, let's me try to do it manually again here. So let's take this argument. Oh, another thing that we want to do. No, this is fine. Value star argument list, a 64 argument count. Let's do this way. Value star args is so, and like this. Is this okay for you? So this passes just fine. But if I put it inline, it does not. This is very, very strange. So that still passes correctly. I feel that we might have an issue with vararg expansion, as I mentioned before. So let's just continue manually converting this into what the macro should expand to, and then see what is going on. Okay, so this works. But the macro version does not. And this is very, very strange. Okay. Let me bring back this over here, and I will show you why I want to do that in a second. There is this, when you work with macros, sometimes you want to figure out what the hell is going on when you try to expand this. So a trick I do is I wrap all the includes in this if and def actually, if and def macro debug and if. What that does is now if I specify this define, then none of these will actually be included in the output, or none of this will be included in the file. And I can do the following command. I can do cl/p, which is like, I guess, preprocessor. So it causes to expand the macros, but it doesn't do anything else. And we specify the file. And I believe it's /d macro debug. So if I did everything right, then yes, I did everything right. So /d just defines something like you would do in a macro, and /p, as I said, turns it into just the preprocessor, and it outputs this .i file, and you can look at what the macro would expand to, which is super, super helpful for us to do now this debugging of what is going wrong with our code. So these ones I think are actually perfectly fine. It was the other one that was not working. And here we can very easily check this out. Where is this one? It was this one, right? So we have the one that works and we have the one that doesn't, and we will now do them side by side, and it will be super easy for us to understand what is the difference and why one works and the other one does not. Okay, let's do this expansion and see what is going on. What is the name of that function? Partially applied function. Okay, so we are here, and let's try that out. So we have return, we have ID, we have this, and this stuff, and oh, I think I know what is wrong. Let me just check. Yeah, this is a typical mistake in the macro. I forgot that I have a semicolon at the end. Over there. Okay. So before we jump into this, let me clean up this one. So this is no longer necessary. So now this passes. As you see, this is quite a useful debugging option. So let's continue with changing our calls. Arguments. Yeah. This is especially a bad case of why we are doing what we are doing. Because we have a gigantic list of stuff that we want to call with. And it's very nice if you would be able to do it like this. Now, I believe that it's okay that we are like having basically copies of the things inside the function inside of our macro. I need to verify that, but I believe that if you put something into size of, it's not actually run as code, and instead it just uses return types. So it's okay if we do that. Okay, one more. Call puts value message value. Great. Call fib -1 and call fib -2. This kind of decluttering is really, really nice. Now let's see if we broke something. We did not. Everything is great. One last thing is to move the macro back to its rightful place. And I think I will keep this macro debug option available just in case we need it for something else. Good. It builds, it runs. I think today will be this quite short episode, but it's nice to have a change of pace between very long ones and very short ones. And tomorrow we will continue with function calls and do one last thing, which is right now we don't support arguments that are larger than 8 bytes. And if you want to fully have compatibility with Windows call convention, then we do that. But for now, that's it. Thank you very much for watching, and see you then.